So now we're actually going to start an introduction of concepts you'll be exploring further in your calculus classes. So really this is beyond the scope of pre-calculus, and it's an introduction to what you'll see next year. So the goal for what we're going to be doing in this chapter is learning how to evaluate functions using numbers very close to a specific value instead of using the specific value itself. Now, the reason we do that is because sometimes you can't plug the number you want directly in. For example, maybe you're trying to plug in 7, but in the denominator of a fraction, that 7 value makes the function undefined. So instead of using 7 itself, you use numbers like 6.9999999, and that number may not cause the denominator to equal 0. So sometimes we're still able to get information by using the numbers very close to a target value. Some applications you'll see of limits. Of course, there are speed limits. You're not supposed to go above that speed, but really the concept is better demonstrated through things like finishing a race in a certain time, or weightlifters at Olympic events, even speedrunners in video games. In the beginning, there were huge gaps in the time that they were able to cut off from a race, for example. So maybe the next year they shaved 10 seconds off of the race. But now in the more recent Olympics, you're lucky to see even a second get cut off, or a tenth of a second. So what's happening is, while there may still be some improvement and people are finishing certain races in slightly shorter amounts of time, the gaps between the previous years is getting smaller and smaller because there is a limit to how fast they can eventually run it, and there's a limit to how much an athlete could ever bench press. Even if they are occasionally adding a few more pounds here and there, they will never be able to bench press a building, for example. So there's a limit to how much they can do. And then the idea is, so say we're talking about their weights, the amount that they're lifting is maybe still getting higher right now, but the amount it's increasing from year to year is not as big of a gap. So there is a limit going through there saying you will never hit this number. This is like the upper bound. Since I assume you guys aren't familiar with the notation of a limit, I wanted to point out that you're going to see something like this. You'll see lim, which stands for limit, and then underneath that there will be x pointing at a certain number. Now in this case I have c because the number is going to change from question to question, so I'm just using that variable as a placeholder. And then after this part, you're going to see f of x, where f of x will be replaced with some kind of a function. For example, I'm showing you that you'll see something like the limit as x approaches 2 of x cubed. Now f of x is the function that you're interested in plugging the numbers into. So whatever you see off to the right-hand side, that's where you're going to plug the number in. For c, that's the number that you're interested in plugging in, and sometimes you'll be able to plug it in directly, but sometimes you'll have to use the numbers really close to it. For example, in this problem that I have down here, I have the limit as x approaches 2 of x cubed. There's nothing preventing us from just plugging in 2, so the answer is going to be 2 cubed, which is 8. However, we are going to look at some situations where you can't plug the number in, and that's where when I say the limit as x approaches 2, I actually want you to think about numbers like 1.999999 and numbers like 2.00001, numbers that are incredibly close to 2 so that they're functionally the same. So now let's talk about what you'll be doing in the first type of problems for the assignments dealing with limits. And these questions will say something about finding the limit by selecting replacements, or something about picking successive values, anything along those lines for the directions. They mean they want you to pick numbers closer and closer and closer to x to find the answer. So step 1 is to pick a number very close to the given x value for the limit. You will plug it into the function and evaluate it. So for example, on the one we showed here, instead of plugging in 2, I'd be asking you to plug in something like 1.9. Plug it in, see what you get. Once you evaluate that, you'll fill the number into a table. Then you'll pick another number that's in between the one you chose and the number they gave you. For example, a number that's between 1.9 and 2 would be something like 1.99. You're getting even closer to the value of 2. You'll plug that number into the function and evaluate it again. Write down your answer. And you'll keep repeating that process. Usually you'll be asked to do this 3 or 4 times. So then you pick another number between 1.99 and 2. So I would use 1.999. And you're going to keep repeating that process however many times they ask you to do it. So let's look at the example in MATLAB. So here's the first question on the assignment. And what's really nice about the MATLAB one, and you should be able to get through it very quickly as a result, is that they have already filled in the table for you guys. So they said they wanted you to plug the number -6 into the function 3x squared. So you pick a number that's very close to -6, like -6.01. Put that into your calculator, it's going to be some ugly decimal. It came out to 108.3603. Then you plug another number even closer, -6.001. You get this answer. Then you plug in another number, even closer. And the math lab even shows you going from the other side as well. So numbers on the other side of -6 on the number line, numbers that are bigger than -6 are -5.99, -5.999, and then keep going. So what you'll notice is if you're looking at the f of x values we're getting, the y coordinates, you'll see that they're getting closer and closer to the value 108. Same thing from this side. It's getting a little bit bigger, a little bit bigger. It looks like the number is approaching 108. So in this case, your answer is 108. Now, I will also point out that on this example, there was nothing preventing us from just putting -6 into the function. So it's not even a bad idea to just say, what is -6 squared, and then multiply that answer by 3. That's how you'll get your answer here. So the nice thing on the Math Lab assignment is the table is already done for you, but I will show you an example at the end where I'm going to have you guys create the table yourself. Number 2, you can see that sometimes it's not possible to just plug in the given x value. I can't get my answer by just saying what is sine of 7 times 0 divided by 0 because dividing by 0 is undefined, so I won't get an answer from it. But by using our limit concept and picking numbers very close to 0, they chose -0.03, -0.02, -0.01, and then from the other side they picked numbers like 0.03, 0.02, 0.01. So they're showing you that as you get closer and closer to 0 from the right hand side, and as you get closer and closer to 0 from the left hand side, your y coordinates get closer and closer to 7 from either side. So that's the answer we're looking for. On both sides it's increasing, so it looks like it's going to hit 7 and then go back down. So that's how I'm picking my answer here, and that's all you're doing on the assignment. The next thing I want to show you is how to do these for the worksheet part of the homework. Here's the worksheet I will also be asking you guys to do for your assignment. And the idea here is that I want you to evaluate the limit. So for number 1, I want you to evaluate 5x by picking 4 numbers getting closer and closer to 2. So I'm asking you to make your own t-chart. If you want to do the vertical one or the horizontal one, I don't really care. And the first number I'm going to pick to plug in here would be something like 1.9. And then after I plug that number in, I'm going to want to get even closer to 2, so I would pick 1.99. And then I'm going to want to get even closer to 2, so I'm going to pick 1.999. And then I want you to pick a 4th value, so 1.9999. And we're just making a t-chart out of this, so in your calculator, you would say, what is 5 times 1.9? And the answer you should get from that is 9.5. Then you would repeat plugging this into your calculator, but you would use 1.99 times 5, which gives you 9.95. And then you plug in the next number, 1.999 times 5, and you get 9.995. And finally, 9.9995. It's kind of a tedious process, and that's why we'll talk about faster ways to do this over the next few days. But the idea here is that I'm saying as my x values get closer and closer to 2, my y values seem to be getting closer and closer to the number 10. So 10 seems to be the limit. And like I said, on a lot of them, you're able to just plug the number directly in for x. But the reason we use this process is because sometimes you can't plug the number in directly. So I want you to show me this process of making the table so that conceptually you understand what we're doing with a limit, and then I want you to show me the answer. You're kind of making a prediction. If you kept getting closer and closer, what y value does it look like you would hit? That's your limit. And that's all for the notes, guys.